Hey, what's going on, guys? It's your boy C Will back to you with another video. And yeah, what you see here, obviously Intel has been having some issues, and it has officially came out that high voltages, where like single core sitting at idle or all core, depending on if you had your actual your power settings wide open. In the default motherboard settings that all of the manufacturers, including ASUS, it's pretty much, setting all of the, I'll go into some of the settings about it, but they were pretty much having everything set out where it has maximum power to get the highest numbers when it comes to the benchmarks and all this different type of stuff. And I actually did a video not too long ago about overclocking, not knowing that, because I really didn't have any issues with my chip, and I still don't, as far as I could tell. But when it comes to degradation and some of the things that you need to change until they come out with this microcode update. And one of the latest things I just saw is that even with the latest microcode update that's going to come, that they're going to release, I believe through a BIOS update next month, mid-August, it's not going to solve the problem of chips that have already been degraded. So that's a bummer, what I'm saying, because you spend a lot of money on your chip. So the best thing that you could do just up front, if you experience any type of issues with your CPU, go ahead, RMA it, and then apply the actual update on the microcode once you get it out the box. But in the meantime, I'm actually going to show you what my current settings are. I've been scouring the internet, and we're going to switch over to advanced mode here. So I've been scouring the internet and just trying to figure out what's the best settings I could be able to use right now. So I've been playing around with a lot of things. And so here's what I have. I am going to show you my current BIOS settings, and then I'll show you what the interaction is inside of Windows 11. We're running a Cinebench run. We'll take a look at hardware info 64. And then I'll come back and I'll actually make some changes through a current BIOS update, because I'm currently on I believe 1202. Let me see if it shows here. Yeah. So I'm currently on 1202, which I didn't realize actually goes back to like January or April of this year. So the latest update is, I believe, 1402, which does have a microcode update in it, but it's not the one that Intel is going to release. So, and that was like as of like July. So let's just take a look at some of the settings here. I'm on XMP1 7200 megahertz RAM. This is the actual default settings for this, but I also have my RAM tuned. So we'll go into what those settings look like. Just a heads up, after you run a BIOS update, all of your settings get erased back to default settings. So you have to re-put in all the info. Going down here. So I have enforce all limits disabled. And originally I was using the, if you saw my prior video, I was using remove all limits, but keeping it at a 90-degree, thermal ratio. So basically the CPU doesn't go above 90 degrees, which kind of keeps the actual power in check a little bit. And that worked, but really that was just part of the issue. It wasn't the actual whole issue. And as you can see, like my current voltage right now is 1.447. From what I've read, as long as you stay below 1.5, you're pretty much good, from a degradation standpoint. But we've had some chips, that I've seen that inside of the BIOS settings, it was hitting above 1.5, even hitting 1.6, and that's where you start running into issues. So right now I have this disabled. So multi-core enhancement is disabled. What I kind of found out is if you set this up the right way, as you can see, you really don't need this if you set the right things in place. SV behavior is on auto. I've seen a lot of people play around with those. If we go down here, it's auto. DRAM frequency 7200, and this is what my RAM is rated at. It's the I believe it's I have 24 gigabyte sticks. I'll put it in the description below. But I have a total of 48 gigabytes of RAM, and it's rated at 7200. If we go down here to, let me see, performance core ratio, I've seen a lot of people play around with this. It's on auto for efficiency cores. DRAM times, I'm just going to go ahead and show you what this looks like. Here are my timings, how I have it set up. And this has worked for me all the way, stress tests and all that good stuff. Haven't ran into any issues. Let me see. I think I maybe changed something in here. Everything is on auto except trying to see if I change. Oh yeah, round trip latency is enabled. I don't think I had to change anything else in here. Everything else is on auto. Let's see. And here are the rest of my settings. And I gotten these from Billzoid. So yeah, check out his YouTube channel. And miscellaneous timings. I don't think I changed anything in here. I think this is all default. Yeah, that's all default. I didn't change anything in there. I think the rest of this stuff is also default. Yep. DRAM speed configure. I didn't change any of those. Digi VRM. Everything is on default settings here. I didn't change anything. I know a lot of people said that you should change the actual load line calibration to level 4. If you're overclocking, yeah, I didn't get into any of that. Going down here to internal CPU power management. So here's where you need to make a couple of changes. So, and I'm not going to go too deep into this. So I set my amps at 400 amps. And if you had it wide open, so if you had all the limits taken off, this will be like at 511 amps, which is crazy. And then your actual your package power limit would be at like 4,000 something watts, which it doesn't go that high, but that's basically just an unlimited thing. So I actually set this to Intel specific settings, 253. Oh, and I was playing around with this. I actually meant to change this back to 56. I think 56 is the auto setting, not 96 seconds. And so 253 for the long-term duration package limit, and then the short duration package power limit. 253 and 56 is what it's supposed to be. I actually meant to change it back from 96. I was playing around with a couple of things. And from here, it's just all about, nothing else has changed. Everything is on auto default. But these are the actual settings that I put in manually, just to kind of keep the actual chip in place. And then if we go down here to thermal velocity boost, I didn't change anything here. All this is default. I know a couple of people, they play around with some of those settings. Let's see. And down here, I previously had this set at 5 gigahertz for the ring bus. I changed that back to auto. And coming, everything else here is pretty much so. High DRAM voltage mode, I have this enabled and I actually set this at 1.435, which defaults to 1.44 volts on the RAM. And that's just because of I was playing around with the actual my timings and stuff like that. So no harm on that. Additional memory voltages, I didn't change anything here. So all of this stuff is default. And I noticed that when I had this set to enable remove all limits and kept it at 90 degrees, my actual my voltages were getting pretty high. It was bouncing above 1.5 volts, which is dangerous. So seeing that I made these couple of changes, let's go inside Windows and I'll show you what the numbers are, the performance, the temps, and all that different type of stuff, and then we'll come back and do a BIOS update to see if anything changes. Okay, so we are inside Windows 11, and let's take a look at a couple of things. I am going to open up Hardware Info 64. And I will turn the sensors on here. And let me expand this so you can be able to see. So up at the top, the first column is current, minimum, maximum, and then you have average. So let me just kind of spread these out a little bit so you can see. And here, obviously, this is just here's all the clocks. So 14, 15, 16. Yep. So you have 8 P cores, 16 E cores, and yeah, you have 32 total threads. And so here, it'll give you the actual the voltages, and it'll give you what it's currently at, the minimum, maximum, average. Now, also the power plan that I chose. Because the actual power plan makes a difference too. I have it on balance. And the reason why I changed it to balance is because if you watch any of my other videos, I normally turn on ultimate performance, but what that does, it actually makes your clocks run constantly at a high speed no matter what. So your chip never has the opportunity to down clock, as you can see here. So like it down clocks. So which saves energy, but also saves out on the voltages. So I don't know if you're like currently using the high performance plan. I would tell you, you probably need to stop doing that on, I mean, the ultimate performance plan, because it'll constantly have your chip running at high. Because as you can see here, this column right here is the maximum, and the max, is hitting 5.7 gigahertz, 5.6. So it's like my best 2 cores are cores 2 and 3, and those get those boost the highest, and then the rest of the cores, the P cores, with the settings that I chose, 5.7 on the 2 best cores and 5.6 on the others, and then 4.5 on the E cores. So what happens is, when you have the limits taken off, with the 14900K, you actually see these hit 6 gigahertz. And it will bounce amongst the peak core, but the actual voltages will be like crazy high. So the highest voltage we hit on here with my current settings in the BIOS is 1.408. So let's take a look at a Cinebench run. And so you could be able to see how Cinebench on an all core workload, how that reacts. Because right now, when it just sits in idle, again, it bounces around. This so you can be able to see what it is, and then we'll take a look at what the highest temps would be. As you can see here, some of the settings that we saw for PL1 and PL2. So PL1 is the long term, and then PL2 is the short term, and it's maxed out at 253 watts. And then the IA core power is what we'll pay attention to, and CPU package power and stuff like that is what we'll pay attention to once we do the all core workload, so you can see what it maxes out at. Another thing I need to do here is actually change my AIO. I have a 360 AIO, and we're gonna take this from being on quiet. So I have my pump always maxed out 3,200 RPM, but the fans, we're gonna change this to high speed. And actually, yeah, I'm just gonna change it to high speed because that's a real world situation, not full speed. High speed is going to depend on the actual temperature. So you can see the actual how the fan speed increases as the temperature increases. So I am going to go ahead and hit apply on that. And then we kind of move this out the way. Believe my last Cinebench run was 38,136. And let's see what our results are. I'll let this run and then we'll come back. So this usually lasts for about 10 minutes. And as you can see here, for the temps, we are at 81 degrees. And then the amount of power, so you see CPU package power, we're hitting about we're maxing out at the 253, which is good. So it's not running wild. And as you can see, the current, and as you can see, the actual current gigahertz is, so the P core is getting up to 5.3, 5.2 gigahertz, and then the actual E cores are 4.1. And look at all of the volts. So the actual core VID, what's that? Around about 1.2 almost volts. So that's great. And then obviously the max will pay attention to this, but I don't think it's going to go beyond that. But let's keep an eye on the actual max temps. It looks like we're at 88 degrees so far. But we definitely staying under that 100-degree mark. And so sometimes I've seen it spike up to 100 degrees, but it usually has something to deal with changes because I have this on high speed on the AIO. It goes based off the actual temperature. So it'll ramp up and down. But I just want to show you a real world situation, like if you were doing some rendering, or if you was doing a shader compilation on a game and it was taking a little while. This gives you, sometimes it uses up to 80 to 90% of the actual CPU when it's doing a shader compilation in a game. And Unreal Engine 5 and Unreal Engine, that's what some of the issues that people were running into. So this is just a good scenario. Just obviously, your shader compilation shouldn't take 10 minutes, but as the actual cores and AI starts to saturate, we'll get a good indication, about what the actual average temps will be. But as you can see so far, we're at 85. So this is what I'm going to keep my chip at. But we'll see what happens with the actual default settings that Intel has put in place on the latest BIOS update. Again, it's not the one that they're releasing as far as the actual microcode update. It hasn't been released yet, but ASUS has pulled out actual BIOS update as of like July 19th, and we'll take a look at that to see if it changes anything, or should I actually keep the settings that I already have in place right now. All right, let's let this run. Okay, so from what I can see here, it looks like we have, what is that, 38,058. So we were able to, again, replicate pretty much almost the same score that we got earlier. But as you can see here, we're definitely, the voltage going back down. The highest voltage that we hit was 1.457 volts during this actual run. And so that is significantly different from what I was receiving. Like I said, it was hitting over 1.5 volts when you have all of the extra. And I'm not going back to show you the difference in between that with everything just power running crazy. You could go on the internet, see screenshots and all that different type of stuff. I just want to make sure I keep my chip in place. Now, granted, I'm not going to get into the whole controversy about whether or not, obviously we know this is not good, from an Intel standpoint for marketing, how they're taking care of their customers, but they are still doing RMAs. So they're not doing a recall. And the bottom line is that, you know, just like from a business standpoint, technically it's not up to, you know, when you're buying hardware, I know it's supposed to, if you buy an unlocked chip, and I know that there are some, you know, could be issues and stuff with like laptops, server chips and stuff like that. But if you're building your PC, um, you know, I can't really speak on pre-builts because I don't know what type of limits that they put in place from pre-builts and stuff like that. But if you're building your PC, make sure you do research. If you started having issues early on, and we're going to go back into the BIOS because we're going to set, you know, a couple of things straight and see. I'm going to show you what updating the BIOS looks like. But just keep this in mind. When you build a PC, it's totally up to you about how your system is set up. And obviously, it would be nice if they put everything at default limits when you put it in. But at the end of the day, it's still up to you as a consumer to make sure that you check everything because you know, there's a lot of stuff that goes on behind the scenes when they're trying to fight for these biggest benchmarks and stuff like that. And you know, I could have also been a victim because I've been overclocking my chip and all this different type of stuff, and but I've been doing that through the actual the Intel Extreme Utility software. So yeah, it's just a lot of stuff that's going on behind the scenes. But just so you can see, again, this is what my chip boosts up to with the settings that I have. Highest that we peaked, which was what we set the limits to, which is 253 watts. The highest temp was 90 degrees. So we're still able to get performance. And also, you know, whether that's up on an all-core workload and also single core workload. So 5.7 gigahertz is still high. Your chip is supposed to boost up to 6 gigahertz ultimately, but until we receive the microcode update for that, I'm not even changing this back. But it's going to be interesting to see some of the options that we have available with the new BIOS update. So let's get back into the BIOS. Okay, so I made a mistake during the recording process. Right now I'm doing the actual BIOS update. I thought I was recording. It's so crazy. But as you can see, we are updating the actual BIOS. One of the things I just want to tell you is make sure that even so, like this says, you know, during this actual process, one thing I found out with ASUS and Intel is that the system is going to restart multiple times. What you should not do is interfere with the process. It's going to restart. It's going to do all these different type of things. The ultimate goal is going to get to a point where you will get to a BIOS screen that says hit F1 for setup, you know, that you made changes and all this different type of stuff. Just let it do its thing, you know, let it play on out. I'm using an Elgato capture card, a 4KX, which is the newest external capture card. And as you can see here, it says BIOS is updating LED firmware. So yeah, it's going to do all this different type of stuff, which is the reason why I said don't bother it, because you don't, and then you'll be trying to figure out how to unbrick your motherboard, you know, because you messed around with the BIOS, you know, messing around with the system while I was doing the BIOS update. Let it do its thing. This BIOS update will erase any profiles or anything like that that you have set up. It helps to have a fast USB drive. And yeah, so just keep that all in mind as you're doing this. But you know, let everything play out. And this should, so this is the screen that you're looking for. So you're looking for this screen here. Now let you know, say, hey, you made some changes. There's been adjustments to the BIOS, and you hit F1 to enter back into the setup. And it's going to be interesting. So let's hit F7. So when you do BIOS updates, it usually resets everything back to the default standards. So let's take a look. On the right hand side here, I do know it's Intel boards give you the actual SP rating of your chip. If you experience any type of degradation, that number does not change. That's just a default number. It'll give you an actual number of points for your cooler and all that good stuff. And right now, I mean, and it'll give you predictions about your, you know, saying what it maxes out to boost. And you see here where it talks about 1.59. That's bad. That's not good. You know what I'm saying? So it looks like there has been some changes to the BIOS. So like if you pause here, you go back to the beginning of the video, you will know that this is a new setting. So Intel default settings, that's new. So you have a difference between a ASUS advanced OC profile, which I'm pretty sure sets all the limits, and then you have Intel default settings, right? So Intel default settings. So look at this. It says load the Intel Extreme profile and set the ICC max to 400 amps, which is what I was already using. PO1, PO2 to 320 watts. That's the actual max for a 13900KS or 14900KS. And then for the 13900K and KF and 14900K and KF, it'll do the PO1, PO2 set to 253 watts, which is what I was using. So those are the Intel limits. Okay. So Intel default settings. So that's what we want. Then you also have Intel default settings. You have an extreme. So you have a performance versus extreme. So performance limits the actual amps to 307 and 253 watts. So that's performance. So basically, really, it's just the amps that are changing. If you have a 14900K or 13900K, but it also includes some of the actual other SKUs. So that's interesting. I'm going to leave this on extreme. So 400 amps, which is what I was already using. And then we have 253 watts on the power limit 2, power limit 1. So I'm okay with that. Multi-core enhancement is still disabled by default now, so which is good. So the AI overclock tuner is set on auto. I'm just gonna set XMP1. So that's going to give me my DDR5. Now I'm not gonna mess around with the timers right now. I am just going to leave that on auto for right now. Let's see. Everything else seems like it is normal. Let's go inside the Intel CPU power management. And here, so the extreme profile that we chose for Intel settings is at 400 amps. It's going to set so all of these looks like to be settings that we were using once before. So which is interesting because that's what I was already using. So 253, 56, 400 amps. In advanced, so there is something else that's I'm not gonna mess with anything else. Let's actually go back to, I am going to, all right. So all of this is on auto. DRAM voltage, 1.4 volts. Okay. All of that is on auto. Let's see, the system agent voltage. All right. So I tell you what, let's go back into Windows and see what this actually looks like. And let's run another Cinebench. So Intel default settings, and then I chose the extreme profile. Let's see, F10, click OK. And then we'll take a look at some of and now, again, the BIOS update that I did was just the latest one that ASUS had for this board. I have a ASUS Strix Gaming E Wi-Fi 2 board. Phenomenal board, by the way. The only thing that sucks that with Intel is that we're getting ready to go into a different socket. So yeah, you know, whenever Arrow Lake comes out, stuff like that, I have to buy another motherboard. And obviously, you know, another CPU, see what we're going to get on that. But this is going to be interesting to see if we have the manual settings that I was using before I did the actual BIOS update. Is it going to be the same as the actual default settings for Intel choosing the actual extreme profile? Very curious about what that's going to be and what that's going to look like. And which is, it's a shame, because if this works the same way, this is what we should have been using from the jump, right? So yeah, let's take a look. If this kind of puts a couple of things in check before we receive the official microcode, because the issue is that the actual CPU was being fed incorrect VID voltage numbers, and that's the reason for the actual microcode update, basically. So your chip shouldn't be running above 1.5 volts, you know, even at the actual maxed out setting, it shouldn't be doing it. So, which is causing the actual degradation. Whether you're in idle or full core workloads, they were both doing the same thing. I believe my profile for my AIO is still on high speed, and it is. So that's cool. Let's go ahead and open back up hardware info 64. And before we run Cinebench, I definitely want to see what the idle settings are. So looks like so far the max settings 1.438. And if we go down here, I told you my best cores are 2 and 3. And it looks like those are still maxing up to 5.7, then 5.6 on the rest of the P cores. I do see a difference with the actual E cores are 4.4 instead of 4.5. So that's interesting. Let's see. We go down here to the power level. So it's still 253 watts, just like what we talked about. And they set the actual amps to 400 amps with the extreme profile. And yeah. And so we still have this bouncing around, which is fine. We're using the actual power plan that we're on. And let's do a Cinebench run. So our last score was 38,058. I know that says 38,136, but it was actually 38,058. So let's do another multi-core run and see what this looks like. And remember early on in the video, we actually maxed out at 90 degrees in the maximum column. So it looks like we're still around about the 70, 80 something mark. And obviously the longer this runs, the higher it goes up. We're still hitting the 253 watt. And let's take a look at what the actual, so yep, it's still around about 1.2 volts on the actual voltages while we're up on the load. Now, where I do see a drop in the actual boost clocks while it's up on the load. So instead of hitting the 5.3, 5.2, it's more around 5.1, 5.2. And on the P cores, and then on the E cores is at 4 gigahertz instead of around about 4.1, 4.2. So it kind of, messed with the performance just a little bit. But it looks like we're still going to, from the default settings, I believe for, you know, Cinebench R23, I think it was still, I think the default for the 14900K when it was at the actual, the default limits was like 37,000 or something like that. So it looks like we may hit between, oh, right now it's around about 36,000 points. So we'll keep an eye on it. So we may have shaved off about 2,000 points, between 1,500 and 2,000 points, which is fine. But if that means that our chip doesn't burn up, I'm okay with that, you know, and it'll be even more interesting to see what happens, which is the reason why I want to run these tests now before we receive the official microcode update from Intel next month in August. So far, the highest voltage is 1.49 volts, which is very similar to what I was receiving before with my manual settings. So far so good. It looks like we're still just being able. So when you take an average Joe, a person that just wants to come in, they just want to play, and obviously you could probably get even, you know, better results. I would actually still choose the extreme profile from this latest update that we have from ASUS, from the actual BIOS. But obviously you have more options to be able to try to fix your chip. If you already were having issues with degradation, then I don't know if this is going to be a big help for you, but it may still help because obviously it's still putting in checks in place in terms of the actual what your chip is boosting up to, and all that good stuff. So keep that in mind. And also just keep in mind that, you know, sometimes what you may have to do if you're already having issues, you have to downclock the actual chip. And you could do that by going into the actual, the performance core ratio, which will allow you to be able to, you can sync all the cores, but basically it'll sync all your P cores. And so instead of you having some of the actual cores boost up to 5.7, whatever, you can actually set this to whatever you want to set it to. So if this is what the chip is going to do based off of the settings that we chose inside the BIOS, then you know that you're going to have certain cores is going to boost up to 5.7. The rest of the P cores is going to be 5.6. But you can actually go in, if you sync all cores, you can actually lower, you can put it at whatever you want to put it at. So if you want to put it all of the P cores at 5.6 and never boost up to 5.7, that'll lower your voltages a little bit to wherever it is that you need to be stable. But if you have a degraded chip, your best option is really just to not even play around with none of this stuff. Your best option is just to ship it back to Intel, do RMA, get you a better chip, and go in and just choose the actual Intel default profiles until we receive a microcode update. I know it's a hassle. No one likes to ship their stuff off, especially if you only have one computer. I am fortunate enough to have 3, and this is just one of my systems. But yeah, I mean, if this is your only system, that does suck, because obviously if you use this for work or if you want to game and stuff like that, you're going to be down for a while, depending on how long it takes for you to get a new chip back from Intel. I will tell you, if you purchase your CPU from Micro Center, I hope you got their warranty, because their warranty allows you to just take your chip back to the store, and they give you a replacement. So going forward, I'm definitely going to make sure, because I have a local Micro Center in my area, I have 2. I'm definitely going to make sure that I get that warranty on the CPU and motherboard, so I don't have to hassle with the manufacturer. And yeah, so shout out Micro Center, and any other program that's in place. I don't know, Best Buy, you know, I don't know if they have a Geek Squad warranty in place that'll be able to do the same thing, but get you in an extended warranty where you don't have to deal with the manufacturer, because that'll save you a lot of time when you're talking about doing the thing. So definitely didn't want to make this video too long. I just want to show you the things that you could be able to do. One thing I noticed, I actually got some videos that's going to be coming up. Just going to be dealing with checking out some more games, doing some benchmarks. I will tell you, in gaming, it defaults like the actual core clock defaults like 5.677 gigahertz. So you don't see a huge change when it comes to gaming. You still have the high core clocks. You still, I haven't had any issues with any games anyway. But with playing around with these settings, that's what I was able to get to. So I put that in a separate video. But if this video helped you out any at all, make sure that you hit like, hit subscribe, hit the bell so you receive all my notifications. This is your boy C Will, and I see y'all in the next video. Peace.